Hello and welcome to Global Math Mentor. This lesson is about chi-squared test. There are two kinds of chi-squared tests in your course. One is the test for independence and the other is the goodness of fit test. This video is about test for independence, which is part of SL 4.11. So let's see what is given in the syllabus. The syllabus document says that students should be able to formulate null and alternate hypotheses. H0 is your null hypothesis, H1 is your alternate hypothesis. What is null hypothesis? It is the claim that two sets of variables are independent. It means there is no connection. H1, on the other hand, is the alternate hypothesis, which claims that there is some connection, so the variables are not independent. Significance levels are given in the question. It's normally 5%, sometimes 1% or 10% even. P-values we calculate using the graphing display calculator. There's a thing known as contingency table where you find the observed frequencies. And the expected frequencies we do not need to calculate since the GDC can calculate that for us in the application course. Degree of freedom, on the other hand, is also something which the graphing display calculator already calculates for us. Critical values are sometimes given in the question, sometimes not. So you might be wondering that what is a critical value? They give you a critical value for chi-squared. Then you use your GDC value, and I'll show you with an example how to accept or reject your claim. And if this is not given, then you just use your significance levels to accept or reject your H0. I know this is too much, but you can always rewind and listen to this again. Let's take a look at an example. Suppose we want to investigate whether temperature affects ice cream sales. You can see there is a contingency table given in the question, which shows observed data. So now listen to this carefully. This is the observed data. So hot day, high sales, low sales, not a hot day, high sales, low sales. These are just row totals and column totals, and this is the grand total. So the highlighted region is something which needs to be added into the graphing display calculator, right? Okay, so what are we testing? Using a critical value method at a 5% significance level, critical value is given. We need to test this claim. And using the p-value method at a 5% significance level. There are two ways of concluding the test, but whatever the test is, first step is always defining your H0 and H1, right? So the null hypothesis is always that there is no connection. The two variables are independent. So you will say temperature does not affect ice cream sales. And on the other hand, you will say temperature does affect ice cream sales, right? So write always in the context of the question. Don't just write variables are independent, variables are not independent. So write in the context of the question. Okay, this obviously does mean that there is no connection. The temperature rise and ice cream sales is independent. Okay, so obviously you can choose different words, but always try to add the context of the question. Now take out your GDCs. If you're solving with me, that will be good. Go to your MAT on the screen and it shows you matrix. Execute and it asks you for M and N. M is the rows and N is the column dimension. So it's a 2x2 matrix, 2 rows and 2 columns. You can see 2 horizontal rows, 2 vertical columns, right? So press 2 and 2. Watch out in the exam, you might get different rows and columns, so add those. So you see this 2x2 matrix, enter your observed data, which is 45, 15, 20, and 40. So now the observed data is added into the GDC in this matrix A. Now you need to go to menu and the second stats. You see there are different options, but I need to pick the testing hypothesis, and there are different tests, but I am testing chi-squared independence test. GOF is the goodness of fit test, and two-way test is the one which investigates independence of two variables. So go to this two-way. Now the observed matrix is already there and expected matrix is already there. As I was saying earlier, that you do not need to calculate the expected frequency separately. The GDC does it for you. Just execute. And now I need these values. So I'm just taking them and I'm copying it here. Okay. So what the calculator gives me, it gives me the chi-square value, it gives me the p-value, and it gives me the degree of freedom as well. If you want to know the formula for the degree of freedom, you can write it. It's always rho minus 1 times column minus 1. So sometimes the examiner says that state the degree of freedom. So you can do it both way. Either you can do it manually, or just when you put your matrix into the graphing display calculator, you can get this to DF, means the degree of freedom. Okay. All right. So now using the critical value method at 5% significance level, we need to test our claim. So you can see that my chi-squared value is 20.979 something something. If this value is more than the critical value, now this is important. If your chi-squared value is more than your critical value, you reject the H naught. So you will say that there is sufficient evidence to reject H naught. Sometimes you can write in the favor of H1 and conclude, hence, temperature does affect ice cream sales, right? So always write your conclusion in the end. What have you tested, right? So remember, this is a key idea. If chi-squared value is greater than the critical value, you reject H naught. And on the other hand, if chi-squared value is below the critical value, you accept H naught, right? This is method one, the critical value method. Noted somewhere. This is the first time. What's the second way of testing it? Sometime you are not given the critical value. Instead, you are just given the significance level. So for significance level, check what is the probability given in the GDC. This is 4.634 into 10 raised to power minus 6, which can be written as 0.12345 6 and 634, right? So this is a very tiny probability as compared to the 5%, which is 0.05. So your p value is below the significance level. This is also the same criterion. You reject H naught. So you will say there is sufficient evidence to reject H naught. And so the temperature does affect ice cream sales. Now, students, this is something worth noting. How do you reject or accept your claims on the basis of the chi-squared value? How do you reject or accept the claims on the basis of the p-value? There's a slight difference, like p-value, if less than significance level, reject H naught. If chi-squared value is greater than critical value, reject H naught, and vice versa on the other hand. Please do rewind it and note down these steps. Now I'm going to solve an actual exam question. As a part of study into healthy lifestyles, Jing visited Surrey Hills University. Jing recorded a person's position in the university and how frequently they ate a salad. Results are shown in the table. So we have a contingency table showing positions like students, professors, staff, and administration. Salad meals per week. So 0, 1 to 2, 3 to 4, more than 4. So this is the contingency table given. Jing conducted a chi-square test for independence at a 5% level of significance. First part, state the null hypothesis. You just need to state the null hypothesis. Remember context. So you will say that person's position in university, don't use short words, is independent of salad choices per week, right? You can choose different words, but it should have some context of the problem. Calculate the p-value for this test. So now I need to go to my graphing display calculator, press this mat, execute. How many rows and columns do you see? So there are 3 rows and 1, 2, 3, 4 columns. So 3 rows, 4 columns. Let's execute. So you will see this matrix over there. Enter the values carefully. 45, 26, 18, 6, 15, 8, 5, 12, and 16, 13, 10, and 6, right? So always make sure you keep an eye, like, have you entered the values correctly or not? 15, 8, 5, 12, 16, 13, 10. Seems all right. Now go to menu and stats. Go to this test, chi-squared, and you have this two-way test in your GDCs. You can check that. Just execute. And you see your p-value, which is a 0.0201. So p-value is 0.0201. Now, only the p-value was asked in the second part, right? State giving a reason whether the null hypothesis should be accepted. So it's a 5% significance level. Just see what is the difference. 0.05. Is our probability below the significance level or above significance level? They're not asking for the conclusion, just state giving a reason. So you will say, since your p-value is below the significance level, so H naught should be rejected, right? Okay, in the end of this video, I just want to quickly show you where do you find the expected frequencies, right? Go back, go to your number 1, go to mat again, and you will see that the GDC has already filled the matrix B as well. This is the observed values, and these are the expected values. So go ahead and you will see all those probabilities. Rarely the examiner might ask you to get the expected frequencies for a specific group or maybe the whole table. So you can copy it from the GDC as well, right? Keep practicing. Over and out.